Hi, I'm Kelly Macon, and I'm in Mr. Schilling's IB Physics class. For this project, I did some research on how the science of superconductivity applies to maglev trains. The ideas for these trains started coming to life in the early 20th century, and they're now used globally to raise the bar for public transportation.
My name is John Elstead, and I'm currently in SO Chemistry with RISC and HL Physics 2 with Peterson. And for the Group 4 project, I looked into the applications of superconductivity within MRI scanning, as well as put together the mind map and the conclusion sections of the video.
Oh, hey, I'm Max Bergen, and for my Group 4 project, I studied the history of superconductivity, basically what it is. I also contributed to the editing process of the video, and I'm in Berg's 5th period sports class.
Superconductivity was discovered in 1911 when Dutch physicist Heike Kamerlingh Onnes, who was studying the resistance of solid mercury at cryogenic temperatures, observed when the temperature of the mercury hit 4.2 Kelvin, the resistance abruptly disappeared. A substance becomes superconductive when its resistance is zero. So if we look at this on a graph of resistance versus temperature, what happens is the superconductor's resistance slowly decreases as the temperature does until it reaches a cold enough temperature, usually lower than 10 Kelvin, the resistance drops to zero. Superconductors are materials that conduct electricity with no resistance. This means that, unlike more familiar conductors such as copper or steel, a superconductor can carry a current indefinitely without losing energy. They also have several other important properties, such as the fact that no magnetic field can exist within a superconductor.
Machine, superconductivity is used to create a super powerful magnet at a relatively low cost. The magnet can reach up to 2 Teslas in strength due to this and allows for doctors to peer into the human body without actually opening it. An MRI machine essentially aligns all of the hydrogen protons in the body to resonate at a desired frequency, which can then be pinpointed using radio waves. When the radio waves hit the aligned hydrogen protons, they become energized. However, once the radio waves are turned off, the protons release the energy and realign themselves to the magnetic field lines. The rate at which the energy is released is dependent on the surroundings of the hydrogen atoms and allows for a computer to differentiate the types of tissue at that specific point. Since its discovery in the 1970s, MRI has revolutionized the way we see the human body and has allowed for breakthrough research in areas such as cognitive functions and diagnosing cancer. However, all of this is possible due to superconductivity and its ability to create a super powerful magnet at a relatively low cost.
Maglev trains utilize superconductivity to fly at incredible speeds between destinations. Maglev is short for magnetic levitation, which explains exactly how the trains work. Electromagnets have a core of iron, and these are wrapped in a superconductor wire. Together, they line both the bottom of the train and the tracks, and each set has the same polarity, causing them to repel each other. This allows the train to levitate and travel without contact, making it frictionless, produce no thermal energy, and increase the electromagnetic current. Because these trains do not require wheels or rails, they save the raw steel and iron that would be used on a traditional train. They also save huge amounts of fuel, as they are propelled forward by the electricity in the propulsion coils alternating polarities instead of steam engines or diesel. This means that they release no emissions. They save time as well, because they can travel up to speeds of around 300 miles per hour. Essentially, these trains are quick, quiet, and efficient, and therefore a perfect method of modern transportation.
Superconductivity, since its discovery in 1911, has been extremely useful in multiple areas of physics. The idea that you can have zero resistance in something has led to a lot of breakthrough technologies in multiple areas of science. Because of zero resistance, you get this idea of having 100% efficient magnets. And with these efficient magnets, tons of useful applications stem from. So you could possibly have medical applications, which we talked about, such as MRI. You could have transportation applications, like the maglev train, allowing for transportation at speeds much greater than any normal transportation. You can have There are also applications that we didn't talk about within the video that are in physics. For instance, in CERN in Switzerland, they have discovered the Higgs boson particle. Other applications include, due to these efficient magnets, are in generators, where because of the 100% efficiency, they're able to create extremely resourceful generators, extremely efficient generators. And as for the future of superconductivity, no one really knows. I mean, who knows what the future holds? Could be anything, because there are always thousands of applications for superconductivity.